Hey there students, it's Mr. Barker here. Welcome to our first Year 11 Methods video of the year. We're going to be going over some of the things that you need to know about binomial expansion. Here we go! Alright, to show you what you guys need in terms of skills, we're going to start by doing manual expansions on the following three expressions. So we'll start here with, get my laser ready, a plus b squared. Now, this is pretty cruisy. We can expand this by multiplying out. So we end up with a squared plus 2ab plus b squared. I don't think that's going to be too much of a drama for anyone. Then to get a plus b cubed, we can take our result for a plus b squared and then multiply it again by a plus b. So then we're going to take this a plus b and multiply it through this entire bracket here. So we're going to multiply a by a squared, 2ab and b squared, and do the same with b. We end up there with this a cubed plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed, and simplifying that gives us this lovely answer here. So not too bad, but starting to get a bit irritating. Now, if we continue this to question number 3, again, we can find a plus b to the power 4 by taking our answer to a plus b cubed and multiplying a plus b through it. And at this point, yeah, we can do it, but it's starting to get a bit irritating. But after expanding and simplifying, this is the answer that we would come up with. So a to the power 4, 4a cubed b, 6a squared b squared, 4a b cubed plus b to the power 4. Now at this point, if I asked us to expand a plus b to the power 5 and do it manually, I'd be worried that we'd have some riots in the street because that seems like pretty onerous. But fortunately, there is something that we can use as a bit of a shortcut that's going to make this really easy. All right, so our pal, Pascal's triangle, is going to make these binomial expansions really, really cruisy for us. If you've not seen Pascal's triangle before, this is what it looks like. We've got a leading diagonal of 1 on each side down here, and then each of the digits in the middle here is made up by adding the two numbers that are above it. So this 3 comes from 1 plus 2, for example. This 6 comes from 3 plus 3. This 10 comes from 6 plus 4. There are some naming conventions we need to be aware of as well. So our first horizontal row we refer to as row 0. Then we've got row 1, row 2, row 3, row 4, and row 5 with a certain amount of inevitability to it. And what you might notice as well is that the row number is also given in this second diagonal just there. So we've got this first diagonal of 1s that I'm tracing just here, and then our second diagonal is going to give us the row number. So this 1 is in row 1, the 2 is in row 2, the 3 is in row 3, 4 is in row 4, and so on. So to unlock the secret of this shortcut, we're going to revisit our answer to a plus b squared. Now, take a moment with me. We've got a plus b to the power 2. Let's first have a look at our powers of a. So we start off with a to the power 2. It's the same as what we have on the bracket there. We then drop down to a to the power 1. So this a here is a to the power 1. And then there's no a's present at the end here, but let's think of that as a to the power 0, because a to the power 0 gives us 1, and 1 times b squared is still going to be b squared. Let's do the same for powers of b. They do the same thing, but kind of opposite. We start off with b squared, so that 2 being the same as the 2 on our bracket there. Then we drop it down to b to the power 1, then drop it down again to b to the power 0. So we can hopefully come up with a pattern here that's going to help us determine what powers we use for each of these variables. But the other thing that we need is the coefficient for each term. Now, if we look at our coefficients up here, we've got 1 for our first term, 2 for our second term, and 1 for our third term. So 1, 2, 1. And what you might notice there is that that matches the numbers that we have in row 2 of Pascal's triangle. So we've got a plus b squared. That 2 is going to give us our descending powers of a, also our descending or ascending powers of b if you go in the other way. But it's also going to point us to row 2 in Pascal's triangle and give us each of the coefficients that we need to expand that particular expression. And then a little bit faster this time, let's see if this works for our second one. So a plus b to the power 3. So we had a to the power 3, then that drops down to a squared, a to the power 1, a to the power 0. B is going to do the same thing, b cubed squared to the power 1 to the power 0, and that matches that 3 that we've got here. Now, let's have a look at row 3 in Pascal's triangle and see if the coefficients match. We've got 1, 3, 3, and 1, which is going to match our coefficients of 1, 3, 3, and 1. So this pattern looks like it's showing some promising signs of holding up. And finally, let's review our other answer a little bit faster this time. So we've got a plus b to the power 4. So our powers of a descend from 4, so 4, 3, 2, 1, 0. Powers of b descend 4, 3, 2, 1, 0. And our coefficients match the fourth row in Pascal's triangle. So 1, 4, 6, 4, 1. Again, 1, 4, 6, 4, 1. So it looks like we're going to help, we'll be able to use this to help us with some more difficult expansions without having to do it manually like a bunch of suckers. So now we'll look at how we actually use this to, like, what's our mindset when we do an expansion like this one. So we've got a plus b to the power 5. So I'm going to start with a to the power 5. My coefficient is 1, so I don't need anything out the front. And that 5 is going to come from the power I'm raising this, expression to here. Then I'm going to have a look at my fifth row in Pascal's triangle to get the any remaining coefficients. So my 5 is going to drop down here. Power of a is going to drop down by 1. Power of b is going to increase by 1. So 5a to the power 4b. Then my next coefficient is going to be 10. My power of a is going to drop down by 1. Power of b increases by 1. We'll go to the next one, which is a repeat. That's a 10 again there as well. And then you'll see we follow that same pattern through. Our powers of A decrease, our powers of B increase, and we get our coefficients from Pascal's triangle. So something that would have been really, really tedious to expand manually, we could do really just by looking at the triangle and doing it super fast, which is great. So this neat little table gives us the first 3 that we did, as well as what would happen in the previous 2 rows. And just showing you on here, we could do this with any row of Pascal's triangle that we wanted to. So if I pick, say, row 10 along here, for example, we'd be starting off with, if we had a plus b to the power 10, we'd be starting with a to the power 10, then going to 10, a to the power 9b, then 45, a to the power 8, b to the power 2, and so on until we get all the way to the end. So can you imagine how long that would take you to do it manually? If we use the triangle, we don't have to do that. Okay, so for you guys, you need to do expansions that are slightly spicier as method students. So what if we had something like this? It looks kind of similar, but it's a little bit more complicated. Instead of a plus b, we've got 2a as our first term and 3 as our second one just here. So our technique is going to be the same for this one. There's just going to be a little bit more like arithmetic to do, and it might be like a little funny to simplify, but I'm going to show you how this works. So we start off with, we've got our coefficient of 1, which we're going to get from the third row of Pascal's triangle just up here. And then we're going to raise our first term here to the power 3. So instead of a to the power 3 like we had before, now we've got a 2a to the power 3. So I'm just going to leave that as it is for the moment. Then the next one, I'm going to use my coefficient of 3 from the third row like normal. Whee! Then I'm going to do my first term here, so 2a. I'm going to drop the power down by 1, so now it's 2a to the power 2. And I'm going to multiply that by 3 to the power 1. So I've gone from 3 to the power 0 up to 3 to the power 1. We'll go to the next one. Again, I'll use my next coefficient, which will be 3. My power for 2a has dropped down by 1, and my power for 3 has increased by 1. And then lastly, I'm going to have a coefficient of 1, and then I'm going to bump up that 3 to the power 3. So unlike the expressions that we did before, we've done this first line of working out, but we're not actually finished just yet. So what I'm going to do is go through and evaluate each of these terms that we've got there. I'm going to simplify them as best as I can. So if we think 2a times 2a times 2a, that's going to be 8 to the power 3. 8a to the power 3, and then multiplying that by 1 just leaves me with 8a to the power 3. Now the next one, 2a squared, so 2a times 2a is going to be 4a squared, times that by 3 is going to be 12a squared, and times that by 3 again is going to be 36a squared. Then the next one, 3 squared is going to be 9, times that by 2a is going to give me, it'd be easier to go this way first, times 9 by 3 would give me 27, and then times that by 2a is going to give me 54a, and then lastly, 3 squared is 9, and times that by 1 is 27. So no, we don't have any like terms to collect because all the variables have different powers for a. But now we're pretty much done with that. So it's a little bit harder. There's a little bit more arithmetic to do, but we can give ourselves a bit of a thumbs up. So it's a bit of a spicier one. This is more of a methods level kind of thing that we're going to be practicing. And yes, this is something that you need to know. The other thing that I'll tell you while we're here is if you're doing an expansion like this one, you can check your answers on the ClassPad. So this would be a pretty common lower-ish and non-calculator question, but if you're practicing these at home, if you're in main, you can go to interactive, transformation, expand, and then you type the expression in and it will give you the simplified version of whatever it is that you put in there without having to go through a line at a time. Okay, so that's going to be it. Thanks heaps for watching. If you want to check your knowledge, use your, if you expand each of the following, so a plus b to the power 4, 2a plus 2 to the power 3, 2a take 3 to the power 3, if you expand each of those and then check your answers using your ClassPad, that would be a good way to see if you're on track. The other thing I'll leave you with is something that we're actually going to do in class. It's a triangle-y thing with combinations notation. Why have I shown this to you? Who knows? Maybe it's something to think about or explore. All the best and goodbye.